All right, in this lesson, we're going to look at properties of volume. We're going to start getting into volume. That's what our next several lessons are going to be about, volume. You recall you should have learned about volume in a previous course, perhaps in middle school. Volume is the amount of three-dimensional space that an object takes up. So, for example, like a cylinder or a prism, okay? It's how much space the object is taking up, not flat space, space, okay? Total space, three-dimensional space. First thing we're going to do here is explore volume and think of a cylinder, and then in this lesson you're going to see us talk about cross sections a little bit, all right? And think about cross sections being stacked up, okay? And perhaps having this three-dimensional cylinder cut. If you just cut it a bunch of times, make slices, 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 okay? And then they are all kind of like laid out like they are here. All right, you can imagine what that would look like. So these are two-dimensional cross sections of a three-dimensional object. All right. Basically, if you take the area of each of these objects, okay, the area of each of these two-dimensional cross sections, you get the volume if you add all those up. So the area of one cross section, okay, is, and you know the area of a circle, because each cross section is a circle, it's going to be pi r squared. Okay, so the area of each of these circles is pi r squared. If we know r, we could figure out the area of each of those two-dimensional cross sections. How many cross sections are there? Well, however many there are, if you stack them up, that's the height of the object. Okay, so we'll call that h. If you stack them up, that's h. It's the height of the cylinder. That's this right here. And what's the total stacked area? So the total stacked area is actually going to be the volume. And we're just going to multiply, okay, the pi r squared times the h. Okay? It's the base area, all right? The base area, the circle, which is the base of the cylinder, right? The base of the cylinder. Whatever that area is, we just multiply that by the height, and that gives us the volume. Okay, and that's what it's telling us right here. So from this exploration, we can see that volume equals BH, where B is the area of the base. So you're going to see this quite a bit. You're going to see this formula, BH, where B is the area of the base. That goes for all prisms, except that when you have a cylinder, it's a type of a prism, but the base is circular, so we use that pi r squared. All right, we're going to go back and see this in other lessons. But what we want to do here in this lesson here is recall what we learned about the ratios of the areas, okay? And we did this in a previous lesson. So if you have, see how we have a 3-to-2 ratio here, 3-to-2? All right, we've done this before. If it's 3-to-2, you square both of those and you get 9-to-4. So the areas are in a ratio of 9-to-4. All right. So here's this one here. 1-to-5, right? 1-to-5. So we have 1-to-5. So what happens is you'll square those, and you'll get a ratio of 1-to-25 for the area. All right. For this one here, it's 4-to-2. 4-to-2. That reduces to 2-to-1. 4-to-2 is the same as 2-to-1. All right, so I'll do 2-to-1 and then square. Oops, square, square, and I get 4-to-1. 4-to-1 would be the ratio for the area. All right, and we've done this. 4-to-12 is 1-to-3. 1-to-3 squared is 1-to-9, and this one's 1-to-2. 1-to-2. 1-to-2 squared is, that's a square, is 1-to-4. So that's how the ratios work for the ratio of the sides compared to the ratio of the areas. Okay, now we're going to use that to think about how volume is going to come in, because we talked about volume being base area times the height. So we have another dimension here. Now base area, we already know the base area is a square ratio. So now we're going to multiply by another dimension, which is going to now raise it to the third power. Okay, so that's going to be our factor. It's going to be r to the third. So for volume, all right, it's going to be raising to the third power. We take that ratio of the sides and raise it to the third. All right, so this one is 10 to 8 or 5 to 4. So this is 5 to 4. So to find the volume, we're going to do 5 to the third, 4 to the third. So the ratio for the volume of this cone to the volume of this cone is going to be 125 to 64. So for every 64 cubic units of volume in this one, it's 125 cubic units of volume in this one. That's what that means. This one is 2 to 10, 3 to 15, 1 to 5. There's our ratio, 1 to 5. So 1 to 5, if you cube that, because it's 1 to 5, you could write that like this, 1/5, right? 1/5 cubed, 1/5 cubed, same thing. It's going to be 1 to 125. So the volume of this one is going to be 125 times more than this one. And these are not drawn to scale, obviously. See, this is a 2 and this is a 10. That's not drawn to scale. That one's got to be 10 times. If it was 2 and 10, it would be much bigger. So they're just not drawn to scale, because obviously this box doesn't look like it's 125 times bigger than this one. But if it was drawn to scale, it would. It would be much, much bigger. All right, so you could fit 125 of these boxes into this box. This one here is 4 to 4 to 12. 4 to 12, that's 1 to 3. So it's going to be a 1 to 3 ratio. We're going to cube those, and it's going to be 1 to 9. All right, so the volume ratio will be 1 to 9. And then this one here, it looks like 3 to 2 is the ratio. So 3 to 2, and then we're going to cube both of those, and it's going to be 3 cubed is 27, and then 2 cubed is 8. So the volume will be 27 to 8. So for every 8 cubic units in this guy, you can hold 27 cubic units inside that guy right there. Those are triangular prisms. All right, couple examples here, and then we'll be done with this lesson. A right circular cylinder A has volume of 2,700 and radius of 3. Right circular cylinder B is similar to cylinder A and has a volume of 6,400. Find the radius of cylinder B. So we have A. We have cylinder A, where the volume, I like to write out my information. The volume is 2,700, and the radius is 3. And then for cylinder B, my volume is 6,400, and my radius is unknown. Okay? So what I'm going to do here is figure out, I'm figuring out my ratio. My ratio is radius to radius. So it's going to be radius of A over radius of B. And again, that's got to be cubed, because we're talking about volume. So it's the ratio cubed equals, and then it's going to be 2,700 over 6,400. Now we did these with area. Now we're just doing them with volume. Okay, so now it's going to be, now I already know this one. I know the radius of A, so I'm going to plug that in. It's going to be 3. So 3 cubed is going to be 27. So it's 27 over R cubed. I have to cube that, right? Equals 2,700 over 6,400. Now I cross multiply. It's 2,700 R to the third equals 172,800. I did this ahead of time. Divide by 2,700. Okay, and R to the third is 64. And then if I know R to the third, I do the opposite root. So I do the cubic root, And if you're not sure how to do that, I will show you in class on your calculator how to do a cubic root tomorrow. But basically, you're figuring out what number times itself 3 times gives me 64. It's not 8, because it's 8 times 8 is 64, but that's only a square root. That's 8 times 8. It's actually 4, because 4 times 4 times 4 is 64. 4 times 4 times 4, you need 3 of them. That's why it's a cubic root. All right, it was r to the third. 4 to the third is 64, so the radius would be 4 in this case. All right, and in this last example here, we're going to be using a density formula, mass over volume. Now, this formula will be given to you whenever you need it, but you should know density equals mass over volume. It's not that hard to remember. D equals m over v. It could be used to find the density of a substance, or find the mass if you know the density and the volume, or find the volume if you know the density and the mass. In this case, they're giving us a square metal plate has a density of 10.2 grams per cubic centimeter and weighs 2.193 kilograms. 2.193 kilograms. The problem here is, notice how it's grams and kilograms. So we got to convert. We have to convert to grams, since the rate is given in grams. So we're going to convert 2.193 kilograms. You just got to multiply by 1,000, okay, times 1,000, because there's 1,000 grams in 1 kilogram, and that ends up being 2,193 grams. So really, we're going to be using 2,193 for the weight, and that is the mass. That is the mass. So this is the mass. All right, and this is the density right here. All right, and then we want to find the volume. So density is 10.2 equals mass. We just said 2,193 over volume, which we're finding. All right, and so it's 10.2 V equals 2,193. Divide by 10.2. Divide by 10.2, and the volume equals 215 cubic centimeters. All right, 215 cubic centimeters. That one's not that bad. And then part B, if the base of the plate has an area of 25 cubic square centimeters, determine its thickness. All right, so volume equals base area times height. We talked about that, base area times height. We know the volume's 215. The base area is 25. Find the height, which is the thickness. Divide by 25. All right, and then the H equals 8.6 centimeters. So it just these real life applications, we're going to be doing a lot of them as these lessons go on. They just take practice and trying to get used to what they're asking and what's given, and kind of setting it up. Then I think it'll be a lot easier for you as you practice those and get a little bit better at them. All right, see you in class tomorrow.